Welcome to Probability and Statistics here at Northeastern College. Alright, let's go ahead and get started with our very first section. This class you're going to find is not quite like the regular math class that you took before. This class requires us to know a lot of different definitions, and we're going to do a little bit of computation as we go along. So let me go ahead and define what a statistic is so we can all get started. And I will do my best trying to keep you engaged and also using different types of examples, okay, that's happening around the world to kind of get you relate to the topic of statistics and probability. So what is a statistics? It's a science of collecting, organizing, summarizing, and analyzing information to draw conclusions or answer questions that you may have. Alright, it actually provides a measure of confidence in any types of conclusion. It provides a confidence in our conclusion. So if you wondering what is the, for example, what is the unemployment rate, you can look this up. Okay, you can actually look this thing up. If you just Google it, you can look it up. All right, and the numerical value that you're gonna find, okay, will show you the unemployment rate. So the way they come up with the unemployment rate, okay, they go by some sort of collecting their data, organizing, summarizing, and analyzing. So in this class, we really need to think about all these statistical data that people present to us, okay, the way how they collect it, how accurate they are. Those are the things that we got to keep in mind. Our lives are dictated by statistical numbers, okay. You might hear on the news, you know, where crime rate is real high, the murder rate is real high in the city like Chicago, Illinois. Well, when people on the news telling us those kind of stuff, you know, you need to actually be aware of how they get that numerical value, okay, and how accurate it is. Okay, we can't just, you know, trust everything that people tell us. Okay, there's got to be something they done, okay, that will provide a measure of competence. Alrighty, the word data, okay, are the counts, measurements, or observations gathered about a specific variable in a population in order to study it. Okay, so all the data that we collect, all right, are basically from different type of counts, measurements, or observations. Population, the word population is referring to a particular group of interest, okay, that we're trying to study. For example, like a household income. Well, let me say it correctly. Oops, sorry about that. Let's undo that. Maybe something like a median household income. In the United States. Alright, so that will be the population. The population will be the entire, there will be all households, okay, in the United States. That will be the population, for example. And you can actually look this up. There are different ways of measuring the median household income by breaking down by the state. Alright, sample is a subset of a population which the data are collected. Okay, one of the things you gotta be aware is questions like median household income in the United States. That type of data is almost impossible to collect. It's not practical to ask every single household in the US and ask them what is the median household income. So instead of collecting data from the entire population, we can actually collect different samples, okay, throughout the different region of the of the states, and then expand it to the entire US. So the samples are the subset of the population, okay, from which data are being collected. So the sample is always going to be smaller than the population. As we collect more and more samples, okay, the whole idea of this course is we're going to take a lot of samples, and eventually all those samples can help us, okay, to can help us to figure out what the what the true population, okay, is going to be. That's the basic idea, and you will hear me saying that over and over as well. Alright, a variable is a value or a characteristic that changes among the member of the population. Okay. A census is a study in which data are obtained from every member of the population, and we take a population census every 10 years as well. Okay. And the way how they collect the census, is they have so many different ways. People knocking on your door, people send you stuff in the mail, want you to telling them how many people is in your household. Okay, there are different ways for them to collect, and the census is as the population census is as accurate as you can make them. So the concept here is what we really want to do is analyzing the data of a population. However, instead of collecting data from the entire population, what we're gonna end up doing is taking many small samples of the populations. Okay, eventually that will include majority of the population size. Alright, let's try some example here. Determine whether the statement describes a population or a sample. This problem is a little bit tricky because you got to read the entire statement and trying to think whether the numerical value here is describing population or sample. So this one says the height of 13 out of 35 corn plants at Mr. Leonardo's greenhouse. So the number 13 is referring to the sample. The 35 is referring to population. But the entire statement here is talking about the height of the 13 corn plants. So the numerical value 13 got to be the sample. Now we do not really know whether this 35 is truly the population or not, because he might have more corn plants in that greenhouse, more different types of corn plants. Okay, so this statement might just can be viewed as describing just one type of corn plant. So that 13 is definitely a sample. Let's try another one. The number of hours the children in Mrs. Smith's kindergarten class sleep in the day. The number of hours the children sleep. Okay, so they might say 3 hours. The number of hours, 3 hours is the children, is the hour that the children sleep in Mrs. Smith kindergarten. So the entire statement is describing all the children in Mrs. Smith kindergarten class. So that will be a population. The hours, 3 hours. They sleep. All of them sleep 3 hours. Okay, all of them will be the population. All right. Identify the population being studied in the statement. The height of 14 out of 27 okra plants in Mr. Leonardo's greenhouse again. Okay, so choose the appropriate. Choose the appropriate response. Which one? So what is the population? All the okra? All the okra in Mr. Leonardo's greenhouse? The 14 okra. Well, we know the 14 okra is the sample. All the okra in the greenhouse. That's not really correct. In whose greenhouse? So it got to be all the okra plants in Mr. Leonardo's greenhouse. That got to be the population. So that tell you that 27 may not be the population, like I mentioned earlier. That could just be a type of ochre plant. So we're going to talk about all the ochre plants. That will be the population. Oh, sorry, this is a duplicated problem. Alright, identify the sample. The number of times 13 out of 22 students on your floor order takeout in a week. And the sample got to be the 13 students. Alright, that would be the sample. Identify the population being studied and the sample chosen. The price of homes of a sample of 24 parents of your classmates. Alright. Who is a population? Who is the sample? Alright. We got to be the first one. All parents of your classmates, and the sample got to be those 24 parents of your classmates. Okay, price of homes of a sample of 24 parents. So you already know that 24 is a sample of all your classmates. Got to be the population. Alright, so hopefully with these examples you can kind of get a feel for what population means and what the word sample means, represent as well. Alright, now we classify statistical numbers into different types. What is so-called sample statistics are a numerical description or numerical values of a sample characteristic. That means the sample we collect, all the samples in that particular group has the same characteristic. Okay, and we know we can use them as numerical descriptions. A parameter is a numerical description of a population characteristic. So the word sample referring to sample, the word parameter is referring to population. Okay. And then the table that here is in the textbook, okay, kind of help you to separate population versus sample. And one of the key things here, alright, one of the things here, population associated with the word parameters. Parameters are generally unknown because the word parameter is referring to population, and what we want to find out about the population is generally unknown. Okay, and that's the reason why we are using samples. Okay, taking lots and lots of samples to figure out, you know, things like the median household income or the unemployment rate. All right, and sometimes we can actually fix the parameter. Okay, we can set a particular number for the parameter and trying to use samples, you know, numerical value from the samples, trying to see if it will fit in there. So statistics changes, okay, within the samples, and that's a very, you know, that's a very strange idea. Why the word sample statistic change based on the sample? Because, as you know, people living in different part of the United States are different. Okay, using median household income for example, median household income is going to be higher in the northeastern states compared to the southeastern states. Okay, because northern states are generally more populated in the major city. So if you're looking at within the state of New York, a lot of people live in the city of New York, but there's also a lot of other small towns in the country area in the state of New York as well. Okay, so when we're taking different samples at different part, okay, at different part of the region in the United States, those numbers would be different. All right. So let's try some example here. Let's see if we can look at these numerical values and see whether they are describing populations or samples. All right. It says a recent poll of 1266 corporate executives shows that the average price of a corporate executive car is $45,000. All right, the car is $45,000. The recent poll of 1,026 corporate executives. So this 1,266 got to be the sample statistics. Okay, these guys, that car, average price of the car is $45,000. So that's simple. Right. Same thing. The average number of hours students in your stat class study per week is 15.8. So this number 15.8 is the average number of hours students in your stat class. So students in your stat class is got to be the population because it's all the students. Okay, that's all the students together. The average study hours is 15.8. So that numerical value describing the population. All right, we will talk a lot about this word parameters and sample statistics as we go along this semester. These two words will keep on popping back up. Okay, and I'm not exactly telling you what the word parameter, what numerical value includes with a parameter. We will talk about that later on the semester. All right, there are different types. There are different branches of statistics. Okay, statistics has been grouped into two major branches. One is called the descriptive statistics. The other one is called inferential statistics. Descriptive is what we're going to learn in chapter 1, chapter 2, and chapter 3. Okay, inferential will be something later on the semester. Descriptive statistics as a science gathers, sorts, summarizes, and displays your data. So most of the time, different tables or different graphs that you see in the textbook, in the newspaper, or online, those are considered as descriptive statistics. All right. So descriptive statistics use numerical summaries, tables, or graphs to display different type of data. And most of the time, in other courses that you take, normally they talk about descriptive statistic. Now, inferential statistic is a little bit higher level. As a science, it involves using descriptive statistic to estimate the population parameters. Okay, that's a very important concept because this stays with us at the end of the semester. So inferential use descriptive numerical value for the descriptive statistic to actually estimating, okay, what the population parameter is going to be. Okay, and we're focusing on that toward the end of the semester. So inferential statistics take results from a sample and extend it, okay, to the population to measure the reliability of the results. Okay, how good that result is. And using the recent presidential election, for example, Hillary Clinton's statistical results before the election, she was up by 5 to 10 points in many different states. Okay, so ideally, statistically, she actually won the election before people voted. But for some reason, after the election, for some reason, Donald Trump won. Okay, and that statistically that was very, very strange result. So that tells us that from the statistical point of view, maybe a lot of those exit poll, a lot of those samples that the pollster took, is not as accurate as we thought them to be. And traditionally, those exit poll numbers are quite accurate. Okay, so that was a very strange election from the statistical standpoint of view. So the samples are the different exit polls at different places throughout the country, and we use that. The pollster used those sample number to extend it to what majority, okay, of the country is thinking, which Hillary is supposed to win, but she ended up not winning. So the reliability was actually not there, okay, for that election. For some reason, one of the very first time I noticed that exit poll number turned out to be not as accurate. All right, let's try some example here for our determine whether the statistic describe descriptive or inferential. Okay, let's see if we can figure this one out. The average car price at the new car dealership in town is $29,000. Okay, so the word average price, all right, in this town is 29,000. So that got to be descriptive. Alright, I'll give you another example, okay, for inferential. A recent poll of 1,489 corporate executives showed that the average price of a corporate executive car is $37,000. This statement is, you got to read the statement a little bit carefully. They take a poll, all right, and then they sample 1,489 corporate executives, and it shows out of all those almost 1,500 people that the average car price of a corporate executive will be $37,000. So they are using the sample, okay, they are using the descriptive result, sample result, to extend it for the entire population. So this $37,000 becomes extension to the population. So that means what the statement is trying to tell us is that means that all these corporate executives, all of them, their average car price will be $37,000. Okay, all of them, not just the 1,489, maybe even more than that. So when we extend it to the population, when we use sample extend to population, that will become inferential. All right. So as you can see, this class we do some math, but we do a lot of thinking of these different wordings. Okay, so you're gonna find this class is a little bit strange. It's not like a regular math class, okay, that you took before. You got to understand these words that I have on the handouts, and some of them will keep on popping back up throughout the semester. Some of them will not. Okay, so we're gonna do a lot of playing on words. Okay, what you're gonna notice is there's a lot of playing on words. There's a lot of kind of like manipulations going on here based on the words. Okay, that's probably something you will notice as we go along. All right, that will conclude our 1.1 section 1.1, and thank you for watching. And we'll see you